my dear children. Welcome to the mathematics class. Today we are going to discuss triangles. In this chapter, we are going to discuss the concepts of the exercise 7.3. Okay, my dear children. In the previous exercise, you have learned the congruence of triangles in the exercise 7.1. What are the congruence rules? What are the criteria you have learned in the exercise 7.1? SAS, side, angle, side, angle, side, angle, 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 side. You have learned these three criteria for congruence of triangles in the exercise 7.1. Do you remember these rules of congruence of triangles, my dear children? You have applied also. Okay, my dear children? Right. Now, come to some more criteria for congruence of triangles. Are you ready to listen the class, my dear children? Right. See, first one, SSS congruence rule. What is this SSS congruence rule? Let us see this point. If three sides of one triangle are equal to the three sides of another triangle, then the two triangles are said to be congruent triangles. Understood this point, my dear children? Right. When you are comparing the two triangles, the three sides in the one triangle equal to three sides in the second triangle, then the two triangles are said to be congruent triangles. To understand this point well, let us take some examples. See, triangle ABC. I have taken triangle ABC. Here I have taken another triangle PQR. In this triangle ABC, AB length 6 centimeters, BC length 8 centimeters, and CA length 7 centimeters. In this triangle PQR, PQ length is 8 centimeters, QR is 7 centimeters, and PR length is 6 centimeters. If you observe these two triangles, if you compare the sides, lengths of the sides of these two triangles are equal. 6, 7, 8. Here also 6, 7, 8. But you should not write triangle ABC is congruent to triangle PQR. Previously I told you, when you are writing that sentence, the vertices, corresponding vertices should be in the same order. Okay, my children. See here, AB side length is equal to PR. Okay. So in triangle ABC, AB, you have written AB. AB length is 6 centimeters. In this triangle, where is 6 centimeters PR? So first write the RP. RP. Next, see here BC. BC length is 8 centimeters. BC length. Where is 8 centimeters? Here. So PQ. So RP, PQ, AB, BC. Understood these two points, my children? Here AB, BC. I have taken these two sides. In this triangle, RP, PQ. AB is equal to 6 centimeters. Here RP, these two letters, RP line segment is 6 centimeters. Next, BC length is 8 centimeters. Where 8 centimeters? Here, this one. So PQ. So in this order only you have to take the vertices. So in triangle ABC is congruent to triangle RPQ, not to triangle PQR. Understood this point, my dear children? Don't be confused here when you are writing the sentence, when you are writing the notation symbolically. Okay, my dear children? Right. Now come to the second example, triangle DEF. Triangle ZXY. Okay, my dear children? In this triangle, DE side equal to ZX. Isn't it or not, my children? I marked by the same lines. Here two lines are there, here also two lines. Means the two sides are of equal length. Similarly, EF length is marked by 3 lines. Here XY side is marked by these 3. Means these two sides are of equal length. Similarly, DF is marked by 1 line, single line. So this ZY side is marked by single line. So it means these two sides are of equal length. In this case, we have to write triangle DEF is congruent to three sides in the triangle equal to three sides in the second triangle. That is why these two triangles are said to be congruent triangles. But while you are writing that sentence symbolically, you should not use alphabetical order, my children. Corresponding vertices should be in the same order. So triangle DEF is congruent to triangle ZXY, not XYZ. Understood this point, my dear children? Please note this point in your mind, my dear children. When you are writing, the two triangles are congruent symbolically, like this or like this. You should not write alphabetical order. You should not write the vertices in alphabetical order. Okay, my dear children? Right. To the next congruence rule, that is RHS congruence rule. Okay, my dear children? If in two right triangles, the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. Okay, my dear children, this especially this congruence rule is meant for right angled triangles. Okay, my dear children, RHS stands for right angle, H stands for hypotenuse, S stands for side. Okay, my children. So in a right angle triangle, the hypotenuse and one side of one triangle equal to the hypotenuse and one side of the other triangle. They should be equal. Then the two triangles are said to be congruent. Okay, my children. To understand this point well, let us take one example. See here, triangle ABC. It is a right angle triangle. Right angle triangle. Right angle is formed at B. See here, triangle PQR. Here in this triangle, this is also a right triangle or right angled triangle. The right angle is formed at point R. Okay, my children. At the vertex R. Now, if you compare this one, what is hypotenuse? AC. What is the length of AC? 5 centimeters. In this triangle, what is the hypotenuse? PQ. What is the length of the hypotenuse? 5 centimeters. So, hypotenuse are equal. Then, one side, either this side or this side, should be equal to another triangle. So, here BC 4 centimeters. This is QR is 4 centimeters. Understood, my dear children? Now, these two triangles are said to be congruent triangles. These two triangles are right triangles, means right angled triangles, and moreover, the hypotenuse in this first triangle equal to the hypotenuse in the second triangle, and one side in this triangle equal to the one side in the second triangle. Therefore, these two triangles are said to be congruent. But when you are writing that sentence, these two triangles are congruent, symbolical form. If you want to write it, that sentence in the symbolic form, you have to write corresponding vertices correctly. Okay, my dear children. So in triangle ABC is congruent to triangle PRQ, not PQR, my dear children. Don't use here alphabetical order. The corresponding vertices should be written. Okay, my dear children. Right. Understood this point, my dear children? Right. In this exercise, we use these two congruence rules. What are the two congruence rules? Side, side, side congruence rule, and another one is RHS, right angle, hypotenuse and side congruence rule. Okay, my dear children, according to the question, we use our previous knowledge also. Means we can use side angle side, or side angle side, or angle side angle, or angle angle side also. According to the question, we can use the previous that three congruence rules also. Okay, my dear children, understood? Right. The concepts of exercise 7.3 were completed. Now let us start the problems, the sums in the exercise 7.3. See page number 128 in the textbook. Okay, my children. Right. Come to the question number 1. First question. Triangle ABC and triangle DBC are two isosceles triangles on the same base BC. And vertices A and D are on the same side of BC. See the figure. Observe this figure, my children. See this figure. This is a triangle ABC. In this triangle ABC and triangle DBC, these two triangles, this bigger triangle and this smaller triangle, both are isosceles triangles. Okay, my children, immediately you have to recall the previous knowledge, the definition of isosceles triangle and the properties related to isosceles triangle. Okay, my children, if AD is extended to intersect BC at P, here AD, this line segment is extended to the point P, that is intersecting the BC at point P. Show that first part, triangle ABD is congruent to triangle ACD. This is the first part of this question. And second part of the question is triangle ABP is congruent to triangle ACP. Triangle ABP is congruent to triangle ACP. Third part, AP bisects angle A as well angle D. You have to prove that this line AP bisects this angle A and this angle D. And the fourth point, AP is a perpendicular bisector of BC. This line is AP is a perpendicular bisector of the line segment of BC. Understood these questions, my children? Understood the question? Right. We have to prove all these four parts of this question. We prove these four parts of this question one by one. Okay, my children? Now come to the solution part. In the adjacent figure, given triangle ABC and triangle DBC are two isosceles triangles on the same base. So, in this triangle, in this figure, triangle ABC and triangle DBC, it is given. Triangle DBC are isosceles triangles. So, since triangle ABC is an isosceles triangle on the base BC, so that other two sides are equal. So, AB is equal to AC. Understood this point, my children? AB is equal to AC. At the same time, in this isosceles triangle, the angles opposite to these two equal sides are also equal. It means angle. What is the angle opposite to this side AB? Angle C. That is angle ACB. Angle ACB is equal to, what is the angle opposite to this side AC? This is AC. What is the angle opposite to this side AC? Angle B. That is angle ABC. Because angles opposite to equal sides of triangle are equal. By using this property, we wrote this result. Let us denote this result as 1 and this result as 2. Okay, my children? Understood these steps? Right. Similarly, triangle DBC is also an isosceles triangle. It is also given that triangle DBC is also an isosceles triangle on the base BC. So, triangle DBC this implies that these two sides are equal. That implies DB is equal to DC. The two sides are equal. Understood this step, my children? Right. Immediately we can use the property. What is the property? Angles opposite to equal sides of a triangle are equal. Then what is the angle opposite to this side DB? This angle, isn't it or not, my children? C, angle C means this implies angle DCB is equal to, what is the angle opposite to this side DC? B, that is angle DBC. Angle DBC. Since angles, let us consider this is the result 3 and this is the result 4. Since angles opposite to equal sides of a triangle are equal. Okay, my children, by using this property, we wrote this step. Understood this step, my children? Right. Now, first part of the question. What is the first part of the question? Triangle ABD is congruent to triangle ACD. Okay, my children? First part. Triangle ABD is congruent to triangle ACD. Okay, my children, we have to prove this first part of this question. Triangle ABD is congruent to triangle ACD. So, AB, see here, AB side equal to AC side. We have already got in the first equation. Okay, my children, AB is equal to, in triangle ABD, triangle ACD, AB is equal to AC. AB is equal to AC from equation 1. From the equation 1, in the first equation we wrote this one, AB is equal to AC because it is an isosceles triangle. Okay, my children? Right. Next, DB is equal to DC. See here, DB is equal to DC from the third equation. So, DB is equal to, or BD is equal to CD. BD is equal to CD from the equation 3. DB or BD stands the same and CD or DC are same. Okay, my children? Understood this step? Right. AD is common side to the two triangles, isn't it or not, my children? AD is equal to AD. This is the common side. This is the common side for the two triangles ABD and ACD. So, by which congruence rule these two triangles are said to be congruent? Yes. Yes, congruence rule. Therefore, triangle ABD is congruent to triangle ACD by yes, congruence rule or simply yes rule. Understood this step, my children? Right. After that, what is the second part of the question? We have to prove that, to prove triangle ABP is congruent to triangle ACP. We have to prove that triangle ABP is congruent to triangle ACP. Okay, my children, we have to prove this second part of the question. Here, in these two triangles, let us compare the corresponding parts. Here, AB is equal to AC. We got from the equation 1. Next, angle ABC equal to angle ACB. We have got from the second equation. Okay, my children, AP is a common side. So, I will write the sentences. In triangle ABP, triangle ACP, AB is equal to AC from the equation 1. We have already written equation 1, AB is equal to AC. Okay, my children. Next, angle ABC equal to, or angle ABP. Angle ABP and angle ABC denote the same angle. Angle ABP equal to angle ACP from the equation 2. we wrote in the equation to C, angle ABC equal to angle ACB. Okay, my children, understood this step? Right. Here, angle BAP, angle BAP is equal to angle CAP because angle triangle ABD is congruent to triangle ACD. These two angles are equal. Isn't it or not, my children? So, angle BAP, angle BAP, angle BAP equal to angle CAP, angle CAP, because triangle ABD is congruent to triangle ACD, we proved. We have already proved this one. So, since these two triangles are congruent, these two angles are equal. Therefore, angle BAP equal to angle CAP. These two angles are equal. So, by which congruence rule these two triangles are congruent? Yes, AAP. Isn't it or not, my children? Right. Therefore, triangle ABP, triangle ABP is congruent to triangle ACP by AAS, by AAS congruence rule. These two triangles are congruent. Understood this step, my dear children? Right. So we have proved angle BAP equal to angle CAP. What is it means? AP bisects angle BAC. Isn't it or not, my children? Means angle BAP, angle BAP is equal to angle CAP. Already proved here. Already proved. So this implies, what can you say about AP? AP bisects angle A. AP bisects. So that is also proved. Now we have to prove that DP is a perpendicular bisector of BC. Okay, my children, we have to prove that one. And DP is a bisector of angle D also. We have to prove that also. Okay, my children, now to prove what is to be proved here? DP is or AP is a perpendicular of AP is AP. AP bisects angle D, and AP is a perpendicular bisector of BC. AP is we have to prove that. To prove this one, let us take triangle DBP, triangle DCP. In triangle DBP, triangle DCP, we are comparing these two triangles. Okay, my children? Right. DB is equal to DC. DB is equal to DC because it is an isosceles triangle. Triangle DBC is an isosceles triangle from the equation 3. From equation 3. Okay, my children? Right. DB is equal to DC. Next, angle DBC angle DBP equal to angle DCP. Angle DBP is equal to angle DCB. Because angles opposite to the equal sides are equal. That this is also written as equation 4. Isn't it or not, my dear children? Right. So these two angles are equal. Okay, my dear children, these two angles are equal. So we have proved angle BAP, triangle ABP is congruent to triangle ACP. We have already proved, my dear children. Isn't it or not, my dear children? Then BP is equal to CP. Isn't it or not, my dear children? BP is equal to CP because triangle ABP we have already proved this one. Triangle ABP is congruent to triangle ACP. Then BP is equal to CP. So, by which congruent rule these two triangles are said to be congruent? Two sides and included angle in this triangle are equal to the corresponding two sides and included angle the second triangle. Isn't it or not, my dear children? Right. Therefore, triangle DBP, triangle DBP is congruent to triangle DCP by which congruence rule? By SAS. Understood this step, my dear children? By SAS congruence rule, these two triangles are congruent. Then what can you say? Triangle angle BDP equal to angle CDP or not? Therefore, angle BDP, angle BDP angle BDP equal to angle, this angle equal to angle CDP by CPCT by corresponding parts of congruent triangles. Understood this step, my dear children? Right. That implies DP bisects angle D. Isn't it or not, my dear children? This implies DP bisects angle D. DP bisects angle D. Understood, my dear children? Right. Let us prove that AP is a perpendicular bisector of BC. Okay, my dear children? Right. We have already proved that triangle ABP is congruent to triangle ACP. We have proved that triangle ABP is congruent to triangle ACP. Isn't it or not, my dear children? Right. So BP is equal to CP by CPCT. BP is equal to CP by corresponding parts of congruent triangles. Okay, my dear children? Right. And moreover, angle APB plus angle APC, angle APB is equal to angle APC. This is also by CPCT. These two angles are equal. angle APB equal to angle APC by CPCT. Okay, my children. And moreover, these two angles are a pair of linear pair, forms a linear pair, and angle APB and angle APC what is meant by linear pair? Angle APB plus angle APC is equal to 180 degrees. Angle APB plus angle APC 180 degrees. Understood this step, my children? Right. This implies angle APB is equal to angle APC. So in this place of angle APC, we can write angle APB. Angle APB plus angle APB is equal to 180 degrees because angle APB equal to, we used this result in this step. Understood this step, my children? Right. This implies angle APB plus angle APB. What will you get? Angle 2 angle APB is equal to 180 degrees. Understood this step, my children? Right. This implies angle APB is equal to 180 degrees by 2. We transpose this number 2 to RHS. Then it becomes by 2. Okay, my children? Understood this step? Right. 2 once to 90 times. This implies angle APB is equal to 90 degrees. So this is 90 degrees. Okay, my children. So here BP is equal to PC and angle APB is equal to 90 degrees. What can you say about AP? AP is a perpendicular bisector of BC. Therefore, AP is here. Let us write that sentence. BP is equal to BC. BP is equal to PC. And angle ABP (90 degrees). This implies that AP is the perpendicular bisector of BC. Understood, my children? Hence proved. We have proved all the parts of this question. Okay, my children? Understood? Right.